In the last section of Chapter 6, we're going to talk about conditional probability. The probability that event B will occur given event A has occurred is called conditional probability. Key word we know we're doing conditional probability is the word given. Conditional probability exists when two events are dependent, so if two events affect one another. So let's find conditional probability using a table. So here are our results from when you took a previous test. And I have it spread out between who completed the test review that I gave out and who didn't complete the test review I gave out, and if you failed the test or if you passed the test. Failing the test here would be a D or an F. Passing the test, I'm considering an A, B, or C. If I wanted to just overall look at this data and see the probability that you passed the test, I would look at everyone who passed, so that's 16 total people, out of everyone, which I count up all the numbers here, which would be 27. So the probability that you pass this test would be 16 out of 27, which is 59%. That being said, sometimes I might want to look a little bit deeper into the data here. So if I'm giving a test review, I'd want to see that that would actually have an effect on increasing your chances of passing a test. So if I want to find the probability that you passed given you did the test review, now I don't care about the whole class anymore. I only care about people who did the test review. So I'm looking at these 19 people. So out of the 19 students that completed the test review, 14 of them passed the test. That's going to be helpful data because now I can see that that's 74%. So I can analyze that data and see that, okay, if you did the test review, that would increase your chances of passing, comparing probability of passing being 59% and the probability of passing given you did the test review being 74%. So an overall kind of equation for conditional probability, for any two events, A and B, the probability of A not being 0 could be the probability of B given A, that line that you see down the middle is a symbol to represent given. The probability of B given A equals the probability of A and B over the probability of A. Another way I could look at this, if I switched it, the probability of event A given event B equals the probability of A and B over the probability of event B. Now, this formula could be helpful in the next kind of example that we do. So in example number 2, Willoughby Eastlake looks at weather patterns at school closings in the winter. And they find that 40% of nights there are heavy snowfalls, and of those heavy snowfall nights, school is canceled 65% of the time. Using that information, I'm able to figure out the probability that it snows heavily and school is called off. Now I'm going to look at the conditional probability formula to be able to figure this out. So the probability that school gets called off given there's heavy snowfall is equal to the probability that school gets called off and there's heavy snow over the probability that there's heavy snow. Now I'm going to plug in the probabilities that I know so far. So I was given that 40% of nights in Willoughby, there are heavy snowfalls in the winter. So I'm going to put that in the bottom there for the probability of heavy snowfall. I was also given the probability that school gets called off given there's a heavy snowfall. So I'm going to put that in its appropriate spot. Now we only have one unknown left, which is what we're trying to find, the probability that school gets called off and there's heavy snowfall. So in any unknown, like in Algebra 1, I'm going to call this x. And now I have a one-step algebra equation. So to solve for x, I'm going to multiply both sides by 0.4. And I get that my missing probability there, so the probability that school gets called off and there's a heavy snowfall, is 0.26 or 26%. Last thing we're going to look at in this video is tree diagrams. So this is just another way to look at your data, especially when there's conditional probability formulas. So in this example, doctors are taking surveys on their patients on hand washing, and they find that 80% of those surveyed claim they washed their hands for more than 20 seconds. Of those who washed their hands for more than 20 seconds, 25% of them got the flu this year. Of those who washed their hands for less than 20 seconds, 60% of them got the flu this year. And I want to figure out a couple probabilities from there. And what I could do from here, since there's kind of two categories of like washing your hands properly versus not, and then getting the flu and not getting the flu, is I can make a tree diagram. So if I want to find, for example, the probability that you wash your hands properly and you get the flu, if I make a tree diagram, I'm going to start by proper hand washing versus poor hand washing. If 80% of people wash their hands properly, that leaves 20% to not wash their hands properly, so like less than 20 seconds. Anytime I branch off in a tree diagram, all the branches should add up to 1. So 0.8 plus 0.2 equals 1. From here, I could look at getting the flu versus not getting the flu. So out of everyone that washed their hands for more than 20 seconds, and then who didn't wash their hands for more than 20 seconds, those who washed their hands properly, 25% of them got the flu, leaving 75% to not get the flu. Those who poorly washed their hands, 60% of them got the flu, so that would leave 40% for not getting the flu. If I want to find the probability of proper hand washing and getting the flu, and remember to multiply, I'm going to follow the branches, and I'm going to do 0.8 times 0.25, which leaves me with 0.2, or 20%. Let's say I wanted to find the probability of you wash your hands properly and you don't get the flu. I'd follow the branches accordingly. I would do 0.8 times 0.75, which would leave me with 0.6, or 60%.